Hi friends, welcome to my channel. Let's have a look at problem 934, shortest bridge. So this is a very interesting problem. So in this video, we're going to share a solution based on traversal algorithms. So in this video and in this solution, we're going to use depth first search and multi-source breadth first search. So let's first look at the statement of the problem. So we are given an n by n binary matrix called grid, where 1 represents land and 0 represents water. So an island is a 4-directional connected group of ones, not connected to any other ones. So there are exactly 2 islands in grid. So this is an important assumption in the statement. So we may change zeros to ones to connect the 2 islands to form 1 island. So this problem requires to return the smallest number of zeros we must flip to connect the 2 islands. So here are 3 examples. So in example 1, the return is 1, and in example 2, the return is 2, and in example 3, so the return is 1. So actually, we can specifically depict the matrix and then check this output. So before we do the code and analysis, let's look at the constraints. So first, this grid is a square grid, and secondly, so the number of rows or columns is bounded above by 100. So this is not a very large number. So grid ij is binary, and there are exactly 2 islands in grid. So this last statement or assumption is important. So with that said, let's look at the method we're going to use. So we're going to use traversal algorithms. So here, the depth first search and the multi-source breadth first search come into play. So we're going to use depth first search to find one of the islands, and then use multi-source breadth first search to find the distance to another island. Notice the quotation mark of the distance here. So here the distance is the smallest number of zeros we must flip to connect to another island. So the idea actually for this problem is very simple. So after we find an island, we expand it layer by layer. Once we match a 1 during the expansion, we stop. And during the process, we just need to do simple counting. So here is a note. So during the traversal, so visited positions will be marked having value -1. So this actually plays the role of the set abstract data structure to avoid repetition. So here is a walkthrough for example 2. So this is the original grid. So here we found 2 islands. This one is here and one is here. So now if we do the expansion, so we get -1, -1, -1 here. So we still do not meet a 1. So we do the expansion again. So we get something like this. So this 0 and this 0 also change to -1. And then if we do the expansion again, we're going to meet a 1. So in other words, we're going to touch the second island. Therefore, we shall stop. So the return for this example is therefore 2. So actually this problem, if we regard the 2 islands as 2 sets, actually we are computing a certain distance of the 2 sets. So with that said, I guess we are ready to look at the code. So first, we are going to do some preparation. We're going to track the size. So the size is length grid. Notice that the grid here is a square grid. So also we want to specify the directions. So there are 4 directions, right? So we're going to write so 1 0 -1 0 0 1 and 0 -1. So with that said, first let's find an island. Find an island. So we're going to use depth first search for this task. So first I'm going to traverse the grid to find a position with value 1. So I'm going to use flag that is 0 at the very beginning. So and then for I in range M, and for J in range M. So we're going to check if grid ij equals 1. If this is the case, we find the position, so we're going to stop. We change the flag to be 1, and then we do the break for the inner for loop. Then we're going to do the break for the outer for loop if flag equals 1. Then we break. So this block will locate a position, right? So then for this, so I'm going to do a stack, so using the position I found for the island. Then basically we're going to use a boundary as a set. So we can think that we can expand from the boundary to touch the second island later. So then we are going to do depth first search. So depth first search corresponds to a container stack, right? So while stack, so then we're going to get the position, say RC, let's see IJ, so still okay. IJ equals stack pop. So then once we visit a position, we're going to change it to be -1. So this way we avoid repetition. So then we're going to increment this position. We determine which direction we want to walk towards. So for DI, DG in directions. And then we're going to have X and Y equals X plus DI, and not X, G. I plus DI and G plus DG. So this is the new position. So first we're going to check if this position is out of bound. So if x less than 0 or x is equal to n or greater than or equal to n, or y less than 0 or y equals n. So in this case we're going to continue. So this is outbound condition. So if grid xy equals 0, so then we're going to add this we are going to add this to the boundary. So let's see, add xy, and also if grid xy equals 1, so we're going to push this position to the stack. So stack append xy, right? So this is the depth first search, so which we are going to get the corresponding boundary and the corresponding island. So with that said, so now let's do the third step. The third step is multi-source depth first search, breadth first search. So for this, first I'm going to use a queue. So we're going to use collections stack the current boundary. And then let's count the steps we need. So steps equals 0, right? So then we're going to do the iteration. So for while queue, then first I'm going to increment the step by 1, and then we're going to traverse the queue. So for that layer, right? So for I use a dummy variable for range length queue. What we are going to do is that we're going to pop from the left. So queue pop left. So this is the position. Then we're going to look at the corresponding 4 directions around this ij. So for di, dj in directions. So let's update the position I plus di, j plus dj. And then we're going to check if this new position is out of bounds, if x less than 0 or x equals n or y less than 0 or y equals m. So if this is the case, we are going to continue, basically follow the above paradigm when we do depth first search. And then we're going to check if grid xy equals 1. Then actually we meet another island. So in this case, we are going to return the current state of the steps variable. So otherwise, if grid xy equals 0, so in this case, we are going to enqueue this position. And meanwhile, because it's visited, so we're going to change the current value of xy to be -1. So actually, this is a full solution, because here, after we do the while loop, in between, there must be something returned based on the assumption in the problem. So with that said, let's do a special case check. So boundary, boundary. So let's see, boundary, boundary set. Tag boundary, boundary, right? So let's do a special case check. Yeah, it passes the special case. So now let's do a generic case check. Yeah, it passes all the generic cases. So here, let's give a quick summary. So in this solution, actually, we used different traversal algorithms. One is for depth first search, and one is for multi-source breadth first search. So the code actually consists of 3 parts. So the first part is actually a preparation, and the second part basically plays the role of finding one of the island using depth first search. So, and the third part is a multi-source breadth first search. So the reason is that we want to find the shortest distance towards another island. So in between, when we do the traversal, actually we make some treatment on visited positions. So once a position is visited, we change the value, grid value of that position to be -1. So this actually plays the role of a set in the basic form of traversal. So with that said, I guess that's about it for this problem and this video. Thank you very much.